So, before we go into hypothesis testing, let us understand a few standard terminology about hypothesis testing. The first is hypothesis itself. So, hypothesis means a supposition or an assumption or an educated guess which is arrived at from observation or reflection and lends itself to refutation, or it leads to refutable predictions. Any conjecture cast in a form that will be tested and can be refuted can be called a hypothesis. What then is null hypothesis? The null hypothesis, or framing a null hypothesis, is the first step in testing for statistical significance. And in a null hypothesis, we assume that there is no association between a given exposure and the outcome. So we did see about the causal hypothesis, which is the starting point for steps in hypothesis testing. So we did see about having a causal hypothesis put forth, or the hunch with which you started your research itself. So we start there, and we already have identified the exposure and the outcome. So the null hypothesis is that which states that there is no association between the given exposure and the outcome. Next, we have what you call the alternative hypothesis. So the alternative hypothesis is where we state that the exposure is associated with the given outcome. Now, let us try to understand this through an example. Now, let us say I have selected a random sample of women of reproductive age group. And among other questions that I have asked these sample of women, I have inquired about the nature of condom use during their most recent sexual encounter. And at the end of the interview, I have tested them for syphilis. So, I am trying to look for an association between condom use and testing positive for syphilis. So that's that. This is the hunch, or this is my research question that I have started out with. Is there an association between condom use during your recent sexual encounter and testing positive for syphilis? Now let us try framing these as hypothesis and state upfront the null and the alternate hypothesis. So let us say I started this study with this hypothesis or this hunch in my mind that probably women who did not use condom during recent sexual encounter were more likely to test positive for syphilis. Now, we all know that all research, we do not entirely start with a clean slate or a blank slate. We start with certain educated guesses and certain hunches. So this here, what I just stated, is my hunch. Now, how do I state the null and the alternative hypothesis for this situation? So I would state my null as this. Condom use is not associated with testing positive for syphilis. So in other words, what I'm saying is that there is no association between my exposure, which in this case is use of condom, and the outcome, which in my case is testing positive for syphilis. So I hope it is clear how we state the null hypothesis, where I'm saying that there is void, there is null association, there is zero association between the exposure and the outcome. Now, next we state the alternative hypothesis. So, alternative hypothesis I state as condom use is associated with testing positive for syphilis. So, if you see here, I am not saying whether condom use is protective against syphilis or condom use puts a person at more risk for developing or testing positive for syphilis. So, this alternative hypothesis where I claim that this given exposure is associated with this given outcome is what you call a two-sided hypothesis. In a minute, we will see a little more about what are one-sided and two-sided hypotheses. So now that we have stated our null and alternate hypothesis, we will begin to figure ways on how to test this hypothesis of ours. So for that, I will be calculating the following indicators from my sample. I will need the number and proportion of women who do not use condoms, and the number of and proportion of women who tested positive for syphilis, and I would need the proportion of women with syphilis in two groups, among women who reported no condom use and among women who reported that they used condom during their recent sexual encounter. So once I have information from my data, we will see how we put them together in the form of our null and alternate hypothesis. In other words, once you've stated your null and alternate hypothesis, what you can do is to try to state them as measurable forms. So, for example, we know that we are looking at association between condom use and syphilis. So, let us try stating our null hypothesis here. So, if my effect size is risk difference, then I would be stating my null hypothesis as follows. Proportion of people testing positive for syphilis among condom non-users minus proportion of people testing positive for syphilis among condom users will be 0, which is essentially saying that these two proportions are equal. So the value that is consistent with my null is 0 because I am stating that P1 minus P2 is 0. What would be the alternate hypothesis? So in the alternate hypothesis, we've already stated that there is an association between condom use and testing positive for syphilis. So to state it with the proportions that I have in hand, basically P1 and P2, I am trying to say that the proportion of those testing positive for syphilis among condom non-users is not the same as the proportion of those testing positive for syphilis among condom users. So if I subtract them, I'm going to get a number that is not equal to 0. So the difference between these two proportions, P1 and P2, is not going to be equal to 0. Let us look at the same if I'm looking at these two proportions and trying to calculate a ratio. Earlier, we tried to present the null and alternate hypothesis using risk difference as a measure of association. Now, let us say I'm calculating a risk ratio, in which case, for the null hypothesis, if P1 and P2 are the same, then P1 by P2 will be equal to 1, which is the value that is consistent with null hypothesis. So, which is again saying that P1 and P2 are the same. The proportion testing positive for syphilis among condom non-users is equal to the proportion of those who test positive for syphilis among condom users. Now, look at the alternate hypothesis. The alternate hypothesis says that P1 is not equal to P2. So, if you divide P1 by P2, then you will get a value that is not equal to 1 because these two proportions are different as per my alternate hypothesis. Now that we're talking about hypothesis testing, which of these two do you test? So we just saw the values that are consistent with the null hypothesis and the values that are consistent with the alternate hypothesis. So for the null hypothesis, if the measure of association or the test statistic is a risk difference, then the value that is consistent with your null hypothesis is 0. Wherein if you were looking at a ratio, then the value that is consistent with your null hypothesis is 1. So you basically have only one value which is consistent with your null hypothesis. Whereas if you look at your alternate hypothesis, the values could be pretty much anything ranging from minus infinity to plus infinity, excluding the null. All values except the value that is consistent with null. So I don't think this leaves much to a choice as to which of these two hypotheses you would be testing. It would obviously be the null hypothesis. And it is always easier to refute the null hypothesis than to prove. So always we talk about refuting or rejecting the null hypothesis because all that you have to prove is that the test statistic or the measure that you have calculated is not equal to the null value. And there goes your null hypothesis out of the window. So this is why we always talk about rejecting the null hypothesis or failing to reject the null hypothesis, because the value that is consistent with the null hypothesis is only 1, and disproving that is easier because you have to show that the value that you have come up with your study is just not equal to the null value. So that's about null and alternate hypothesis and which of the two you have to test in your research. Now that we've heard enough about the null and alternate hypothesis, just take a minute to do this thought exercise. Let us say I have a hunch that I've read from literature that unimproved water source in the household can cause diarrhea in under 5-year-old children in that household. So this is my hypothesis, which is to say I'm looking at the exposure as unimproved water source in the household, and the outcome is diarrheal episodes in under 5 children within the same household. So I leave it to you. You can try framing the null and the alternate hypothesis. You can choose the measure that you will calculate in your study to compare between the two groups, and you can state the values that are consistent with the null and the values that are consistent with the alternate hypothesis. Thank you.